Hello, this is Oliver Birch. I'm currently recording the homework for Lab 2 of my Digital Fundamentals in PLC class. All 6 parts of it. I have 5 multisim drawings laid out here, and I will drag over and verbally explain the 6th part since it's not complicated at all. Going over the different logic gates and how they work and how they would produce different outputs, starting with 1 here. I have part 1, and it simply uses a NAND gate. So when both inputs are, I say true and false, people say low and high, 1 and 0. I'm just going to say true and false because that's how I've always thought about it. 2 false inputs will output a true, and so both of these have to be off, or one or the other has to be off. If both are on, if both are true, then it will output a false. The AND gate only outputs false if both inputs are true, otherwise it always inputs true. So in order to turn the light off, both inputs have to be on, whereas any other combination will produce a true output for the NAND gate. Let's turn that off. Part 2 uses the NOR gate. This one is the opposite of the OR gate, where the OR gate requires either or to be on. This one requires either or. This one requires either or to be true for the output to be false, but if both our inputs are false, then it will output true. So the OR gate would output true if any of the inputs were true. This one will output true, I'm mixing myself up. The OR gate produces a true output if any of the inputs are true. This one will produce a false output if any of the inputs are true. So they both have to be false for it to turn on the light. God, I'm mixing myself up so much. This one over here, part 3, this one has 3 NORs in a row. This one will be a little bit more complicated to explain. Basically, both inputs of the first 2 NOR gates will be coming from the same switch. And so since the NOR gate will output true if both inputs are false, in order to, wait, God, it will output true if both of the inputs are false. So by having either of the inputs false, it will be outputting true. And since there's a third gate here, this one will output false if any of them are true. So currently it's off because this goes from true, or this one goes from false into true, and this one doesn't read any trues. It doesn't like that. And so the only way to turn the light on is to have them both on, where it goes true into false, and then both falses equal a true in the third AND gate. So it's kind of like the third AND gate, the third NOR gate. It kind of works like an AND gate that way with all the inverses here. Part 4 uses this function generator here, this little wave I have set up. So this is the NAND gate. It will an AND gate requires that both are true for it to output true. This one requires both inputs to be true in order to output false. So right now, because one of them is false, it will be outputting a signal to the light. But if I turn this on, if I close it and I input true, then this will output false. But because there's a wave here that alternates between true and false, sometimes this will be true true, and so the light will be on, and sometimes it'll be true false, so the light, or sometimes it will be true true, so the light is off. Sometimes it will be true false, so the light is on. But opening the switch always makes it so that this one is off, so it will never turn this off. The 5th one, I hope I'm not going too fast. This one's complicated for me to explain. Geez. There's a NOR gate here, accepting input from A and B. There's a NOR gate here, accepting input from A and C. Or A and B. NOR 1 accepts inputs from A and B, nor 2 accepts inputs from B and C. But on C, there is a not in front of it, so it's treated as the reverse. And then they go into a NAND. For this light to be off, it requires both inputs be true. Yeah, so for the NAND to output false, both have to be true. And so in order to set up the first one to be true, you have to set up, I am mixing myself up so much. For this one to output false and turn the light off, both inputs have to be true. To make this one output true, both of these have to be, oh no. So yeah, for this one to output true, both of these have to be off. For this one to output true, second one here, oh, I double clicked, then both of these also have to be open. They have to be false for it to output true. But because this one's inverted, this one's treated the opposite way. This one will input false if the lever is set to true and true if the lever is set to false. So we just treat this one as the opposite of the others. We turn this one on. It starts outputting a false into here. And since these are off as well, all of these inputs into these NOR gates are false. It outputs 2 trues into the NAND, and then the NAND will output false. God, I mixed myself up so much there. So that's all the multi-sim drawings. The sixth part of the lab I see here is 2 worded questions. An alarm circuit is needed to indicate that either the temperature or the pressure in a batch process is too high. If either of the conditions are true, a microswitch closes as shown in the following circuit, this one right here. The required output for an LED is low when the alarm condition is true. George thinks that an OR gate is needed, but Betty argues that an AND gate is needed. Who is right and why? Well, seeing as we need to output an alarm when either OR is on, when either OR problem is present, it should be using an OR gate. If one is going wrong and the other one is fine, we want to still output. Of course, if both are going wrong, then we definitely want an output, but we also want an output when either OR is. Accepting one input to output to the alarm, we'll use an OR gate. And a car burglar alarm has a normally low switch on each of the 4 doors when they are closed. If any door is opened, the alarm is set off. The alarm requires a high output. What type of gate is needed to provide this logic and why? So this would also use an OR gate, but because there are 4 doors, it would require 4 inputs to potentially set off that OR gate. So I think this one will require a 4 input OR gate. If any of the doors get opened and it sends a signal into the gate, then it would set off the alarm. It doesn't require that all 4 be open, of course not. Burglars only really need to open one door in your car if they don't go straight through your window. So it would be a OR gate, just like part 1 of part 6 here. And so there. Thank you for listening, and I hope you have a great day.